Hi everyone, let's begin independent t-test. So first what we have to do, we will go there and we will open a file, right? I just want to share with you which file I'm going to use. So this one is independent sample t-test and we will open this file and this file data is loading over here. And then we will share one case. Case is this independent sample t-test. This is the example, and a study was conducted to compare the efficiency of the workers of two mines. There are two mines. One is the private ownership mine, another one is the government ownership. So the researcher was the view that there is no significant difference in their efficiency level. Means those workers are working under private ownership and those working are working under government ownership, both efficiency level is same, no difference. So this is our null hypothesis, and total tonnage of the mineral mined by a worker in one shift was chosen as the criteria to assess his efficiency. So means whatever is the output is coming out, that could be, we are measuring efficiency in that term. So 20 workers from the private sector mine and 24 from government owned mine was selected and their average output per shift was recorded. We have recorded, and these are the, you can see 20 work. This one is the total 44. So we have taken 20 workers till 20. You can see this is the one is coding. One is coding for the private owned mines and private ownership, and two is coding for the government owned mines. And this is the, you can see output in tons. So we want to check, we would apply t-test because both these samples are independent sample. That is why we are using independent t-test. And here is one is the, and that is why variation in the data also. Mine, private ownership mine, this mine is having only 20 workers data, but the government owned mine, this is having 24 workers data. So these are my hypothesis. Average output of the worker from mine 1 equal that of the workers from mine 2. Means there this is the same. But alternate hypothesis is saying average output of the workers from mine 1 is not equal that of the workers from the mine 2. And this is the output I have received from SPSS, and now we will compare both the outputs with the help of Jamovi. So what I'm doing, Jamovi, here it is. I had already opened this file. This is the number of the miners. Total is 44. And this one is the mines, private owned mines and government owned mines. And this is the output. So I'm sure this is the same data that I have discussed in the case study. So what we will do, we will go to analyze, we will go to t-test. And t-test is, here is already we have done one sample t-test, paired sample t-test. And now we will go for independent samples t-test. We will click here, and now dependent variable, that would be output. And what could be grouping variable? And now you can see this is the mines, because we have two categories in the mines. So mine is the grouping variable. Grouping variable means there is the two category. One is government owned mines, another one is private owned mines. So now you can see moment we had clicked here, independent sample t-test, and this is the statistics 2.68, degree of freedom 42, and p value is this. So let me copy this and I just want to paste it here. Then we will compare these results, right? So let me paste here these results, paste it here, right? And I'm just pasting as it is. So that would be better. These results I have pasted here. Now you can see statistics that is reflecting 2.68, right? The same T statistics we have received through SPSS. Degree of freedom 42, and here is also degree of freedom 42. Significance level 0.011. So exactly same results are here, and we are going to describe and explain interpretation of these results, right? Levine test and all these things. Levine test is the significant p-value when it is less than suggesting a violation of the assumption of the equal variance. So means we are not saying there is the equal variance. So that means we are violating this assumption. And here it is also written here, Levine test for the equality. It means equal variance in two groups. T-test for equality of means. And here it is now we can see this is the interpretation. The corresponding two-tailed p-value is 0.017, which is less than 0.05 but higher than 0.1. Therefore, we can reject the null hypothesis at 5% significance level, which means that the average output of the two mines are significantly different from each other. That is, the miners of the two mines do not have the same efficiency. So let me check over here, right? Further, it is, let's say we want to check mean difference also, right? Mean difference, you can say standard error, right? Confidence interval, that would be same because we have taken at the 95% confidence interval. So, and after that, when you are going to click effect size, right? Moment you are going to click here, effect size. So now you can say Cohen's d. Effect size, basically we are measuring with the help of the Cohen's d. And I had already explained in my previous videos Cohen's d, and I would link that one is the video so you can understand. Then we have to understand what are their descriptives. So descriptives you can see in my data, private owned mines 20, government owned mines 24. Mean value of both these kind of mines. This one is the private owned mines. Mean value is 42.5. But the government owned mines 39.1. Median value is this. Standard deviation 5.48 and 2.79. Standard error is this. So this one is the, we can check, and other test also we can run over here. Right. Let's say you want to see descriptive plots, you can see this descriptive plots also that would describe from both kind of data, and it's visible here now. Output of these plots you can see, this one is the first one is the, it's reflecting private owned mines, and next one it is reflecting government owned mines at the mean value at the 95% confidence interval. So now we can see, and you can find it here. This one is the median value, mean value that is reflecting over here, and that is also reflecting here. And you can go for the homogeneity test also, and further it is you can go for the, this one is the normality test also, and QQ plot also, means those are the number of the options are available. So you can just test and you can report and you can interpret. So I hope this video would be helpful to you. So stay tuned and keep watching. And in the next coming up videos, definitely I will cover up more tests on the basis, I'm using in the Jamovi. Thank you. Stay tuned. Keep watching.